see directly into the coronary blood vessels, and that would be a very radical change. Also, with the new MRI, they expect to be able to replace mammography with MRI, hopefully within a year. And most of you know mammography has a very high false positive rate that requires biopsy and other things. And we think the MRI with our unique post-processing will be very different. We also do CT scans right now until the MRI is ready for this. About 12% of all our clients have a score above 90%. More than half are less than age 60. And here's an example of a 45-year-old woman. You can see from the MRI image, she's not obese. She had the highest calcium score in 4 different coronary vessels. She had no family history of heart disease, but she does have very elevated lipids. This data would indicate she has a high chance of a major cardiac event within the next 10 years of her life if she does nothing. She thought she was perfectly healthy and had no awareness of disease. So we're seeing this at about 12% of people, increasing rates in women. We do remote monitoring and for the heart, and that's been very successful. We detected a number of people that have episodic atrial fibrillation. AFib is the major causes of stroke. These people had AFib for up to 8 hours a day, perhaps while they were sleeping, and they had no idea they had it. They're all on anticoagulants now. One interesting case we found just from this remote monitor, this gentleman had complete heart block. He was sudden cardiac death just waiting to happen, and he's now on a pacemaker and thriving well. Our goal is to get a very large data set. We have one of these centers now just down the coast in La Jolla. We hope in 5 years to have over 300 of them. We're talking to a number of groups that want to franchise them, have one in their own company for their own employees, for example. But as we add up the data, we're using machine learning to put all this information together to make much better predictions from the genome. We don't recommend just the genome on its own. The genome in conjunction with all the phenotype data is what's incredibly powerful. Now, we give you in your report a number of things. We estimate your height, your weight, your BMI, your eye color, your hair color. But we wanted to go further in terms of physical characteristics. But I was invited to go on the Chelsea Handler show. I don't know if anybody of you watch it. She wanted her genome report given to her on live television. And I told her that her genome estimated that she would weigh 160 pounds. Her response was, "Fuck you." And I said, well, some of us exceed our genome potential and some of us never achieve it. So it's in part up to you. We wanted to make it even more personal. I was certain that we could predict people's faces and even their voices from their genetic code. So we did a test, a small one on 1,000 people. Just from your digital voice recording, we can actually predict your sex, your age, and your height. Machine learning gives you unusual parameters that come together. We're not yet able to get there from the genetic code. But with the 3D face photos, we're getting better all the time. 3D photos of your face don't make you look really attractive. We smooth them a little bit, But here's the computer prediction from this woman's genetic code alone. Here's a young man, and here's his computer prediction. So if we extrapolate from that to humans, it's a big stretch, but this was the first human genome in the journal Science in 2001. And we've made a lot of progress since then. But healthcare has not made as much progress as it's advertised to have made. If you make it to 50 and you're a male, you have a 30% chance of not making it to 74. In fact, 40% of males will never reach the age of 74. 28% of females will not reach the age of 74. 2/3 of the reason is cardiovascular disease and cancer. In our view of changing longevity, if we could detect diseases like cancer early when they're totally treatable, detect heart disease either from the genome or from early symptoms and prevent it, that we would have a big impact on longevity, and I'll give you some examples of it. We're not ignoring the other third of causes, but we figured we'd make great headway even if we could deal with the first two biggest killers. We built the world's largest DNA sequencing facility, and it's generating a lot of data. We are well ahead of Twitter and now Instagram, and are moving our way up. So we work with Amazon Cloud. We're one of their biggest users. We're in their 1% club, along with video streamers and porn sites. But I think this data is much more valuable. So there's a lot of confusion even what a genome is. Some people think gene chip companies like 23andMe are sequencing your genome. We actually sequence it to make sure every base pair is covered at least 10 times. Because it's not just the genes. We're making most of the discoveries in an area outside the coding regions. That being said, the genome is still not completely sequenced. The blue areas you see is where we have high quality coverage. The gray areas around the centromeres where there's lots of repeats and telomeres, there's still not totally accurate coverage, but you can see our false positive and false negative error rates are extremely low, and we have the best standard in the industry. And just for comparison, when we sequenced 8,000 genomes, we saturated the common variants in the entire world population. And it's those common variants that are measured on gene chips. But if we sequence any one of your genomes, we'll get about 8,000 totally unique variants to you. And so that's the biggest growing part of our database are the rare variants. And the rare variants are the ones that are associated with your personal traits and diseases. We published a paper on the first 10,000 genomes just to show the accuracy and what we could get from it. And we came across several surprises looking at billions of data points. We could find some areas of the genome where you see these downward spikes. If you have a mutation there, it's incompatible with life. These are probably causes of early abortions. And then you can see a huge scattering of a range of importance of variation. So we can tell just from looking at our genome data whether a variant in your genome is likely to cause problems, likely to be pathogenic. The other finding, and this will be published soon, and it's going to kind of turn the research world upside down. The FDA and the pharmaceutical world seem to think that mice are mini humans. They're not. I don't think anybody should be really surprised by that. But when we look at the essential genes in mice, the yellow region, And the essential genes in humans, the orange region, you don't see a great deal of overlap. So using mice as surrogates for humans, for testing drugs, etc., is obviously not very adequate. More surprising to people is the blue area, which is human cell lines and tissue culture. And we've shown as soon as you take a cell out of the human body, it starts mutating rapidly. So cells in culture are not representative of the tissues they came from as a good model. So our view is if you want to study humans, you need to study humans and not animal or cell culture surrogates. Putting all this together, we found we had a chance to do something about how medicine is practiced. Today, it's reactive. You get symptoms and you go see somebody trying to sort out what those symptoms are. We're trying to make it proactive, preventative, highly personalized, because each of your genomes are totally unique, and very predictive. So our goal was to sequence millions, tens of millions of genomes, which gives us a very powerful data set. But in addition, we wanted complete phenotype and clinical data to go with each of those genomes. We're doing clinical trials for a large number of pharmaceutical companies, but the phenotype data you get with those are fairly limited. So we decided to start our own phenotyping clinic where we measured as much as we could with modern instrumentation, including new MRIs. We have a technique called restriction spectrum imaging that was developed at UCSD that allows us to avoid using contrast media in the MRI because 5% of people have an allergic reaction to contrast media. And this technique allows us to do a number of things. Perhaps most importantly, it lights up tumors very brightly. In fact, this was one of our very first clients. We only see people who are self-described as healthy, but the definition of health in the US is very bizarre. This gentleman in his early 50s was exactly like that. He was about ready to go on an extended European vacation and just came in to try the health nucleus as the new advanced executive physical. We found this tumor under his breastbone. You can see the bright light just with this new algorithm we have that lights up tumors. He had it removed a week later. Had he let it go another few months, it would have started to metastasize, and he would have had a 2-year survival period. For insurance purposes or for self-insured employers, this was a multi-billionaire. He had obviously a very high insurance policy. It's not hard to calculate the net present value of somebody with, say, a $30 million life insurance policy living to 90 instead of dying in his early 50s because of a tumor that he didn't know he had. This new technique, in fact, is really fantastic at diagnosing high-grade prostate cancer. Just 15 minutes in our MRI can do this. This is a paper that was published recently. David Caro is our head radiologist. And you can see where these bright orangish yellow areas are is where the algorithm is predicting there's a high-grade tumor. And you see it totally corresponds with the pathology. Not only that, we can actually grade the tumor just right off of the MRI image. And we're developing machine learning to do this automatically. The exciting thing about this, most men know there's 2 types of prostate cancer. There's the kind you die with and the kind you die from. This only detects the kind that you die from. If these tumors metastasize, there's a 28% 5-year survival rate. We've been finding these in roughly 1% of men that come through that consider themselves perfectly healthy. over half of them have normal PSAs and no symptoms whatsoever. Here's just a close-up on one where you can see where the MRI shows the tumor and where the pathology showed it. In fact, these techniques can get combined now with ultrasound, where the MRI image gets overlaid on the live ultrasound, and they can biopsy exactly where the tumor is instead of just random biopsies. My institute, the Venture Institute, paid for all the top scientists and employees to go through the health nucleus. Ham Smith, the Nobel laureate, who's been working with me for 20 years and just turned 85, we discovered this fish-sized tumor in his lungs. We couldn't find any metastases, and it was a very rapidly growing lymphoma. He had no awareness of it. Had he not come in, he would have been dead in 6 weeks. But because it was rapidly growing, it responded really well to chemotherapy and radiation therapy. All his hair has grown back, and he's now at 85, back working in the lab every day. Also with these techniques, I was diagnosed with high-grade prostate cancer. So 2 people responsible for sequencing the human genome and setting this up. We both have our life saved by this empowering preventative medicine approach. We're finding high-grade tumors, metastatic cancer, in 2.5% of all the people that come in over age 50. Those of you who are self-insured, if you have 1,000 employees, that means you have a significant number with high-grade cancer that don't know it, but could easily be detected. Every case we've had has been 100% accurately diagnosed by the radiologist, and everybody's been treated and has been cancer-free because we detect these early. We have a genome cancer sequencing program at Human Longevity that's much less satisfying. It's people with reactive health care. We're dealing with 4 women in their 30s that have stage 4 colon cancer. You're not supposed to even get a screening for colon cancer till you're 50, but we see it moving earlier and earlier into women at younger and younger ages, and the same is true for heart disease. So I can tell you it's 1,000-fold more satisfying to detect tumors at stage 0, stage 1, or stage 2, where thus far they've all been 100% treatable. That's not the case with stage 4 cancer. Exercise won't reduce your organ fat. And I said, why didn't you tell me that 15 miles earlier? So the only thing that will do it is calorie restriction and controlling your diet. We're finding fatty livers in 23% of all age groups of people that think they're normal. And we get very quantitative pictures like this that will give you your exact extent of organ fat versus your peripheral fat, your exact muscle content, etc. And for longevity, it's probably no surprise, but your muscle mass is a much more important predictor of longevity than your BMI. Because if you lose muscle mass, you lose motility, and things then go downhill very rapidly. Again, with this algorithm we have, without any contrast media, we get beautiful pictures like this of your vasculature from head to toe. This makes it very easy to see if you've had a brain injury, a stroke, or more importantly, as in this picture, that small bleb there in that U-shaped area is a brain aneurysm. We're finding brain aneurysms in 1% of all people we see The majority of these are under age of 50. Almost everybody knows somebody that's died from a brain aneurysm. That's usually how they're detected. They burst and you have a massive stroke or just die. It's not a very good diagnostic method. They were also discovered inadvertently if you were having brain imaging for something else. These can be now treated as an outpatient with interventional radiology. They just put a coil in there, and that takes the risk from very high to 0. 1 in 50 in the US have an aneurysm somewhere in their body, but 1% have brain aneurysms, which are clearly dangerous. We do 4D echo, and we get these beautiful videos of people's heart where you can measure all the parameters of the heart muscle. You can see the valves. We do Doppler shifts so you can see whether there's any regurgitation. But now with the new Siemens MRI, as part of the hour-long exam that includes all these things, it does automatically a comprehensive heart exam. And we get these beautiful movies of the heart where you can see the blood flowing through it. And by the time you're out of the MRI, the report is finished on the exact quality of your heart. This is a CT scan of my own heart. I use this for HR meetings to prove that I have one. But in a year without contrast, the MRI will be able to see directly into the coronary blood vessels, and that would be a very radical change. Here's a young man, and here's his computer prediction. The more diversity the background of the person, the easier it is to make accurate predictions with the database that we have. So African Americans, here's the prediction straight from his genetic code. Now remember, this is just the face mask. It's not the shape of the skull. It's not the hair. We don't even put in the eye color or eye shape right now. If you look around at the person next to you, the first thing you focus on is not their mask. It's their hair, their eye color, their shape of their face, some other parameters that go into our identity. But almost everybody can recognize their own computer prediction. It predicts what you look like just post-puberty, so 16 to 18 in most cases. And most people can pick 1 out of 10 of these computer predictions. When we have 100, they start to look much more similar, particularly Caucasian males from Northern Europe. Other races have always said that Northern Europeans all look alike. Well, the computer sort of says that's true. We just don't have a large enough data set of Northern Europeans to make fine distinctions there. We want to give people the prediction of their face and all these other parameters so you know all the risk factors we give you are very personalized for you. They're not Aunt Millie who could drink a quart of booze a day and smoke 3 packs of cigarettes at age 99. This is you. We all have a few hundred to a few thousand unique mutations that make us different from our parents or our twin brother or sister. And our goal is to put all this data together with machine learning and our what we call our health intelligence cycle to make predictions. And we're working towards getting enough data to make more and more accurate actuarial predictions. But if you think about your own employees and you apply these statistics to them, not only is this a tremendous employee benefit because you save quite a few lives and make people live longer and healthier, it's extremely rewarding when on a daily basis somebody's life is saved by going through this. Medicine has been a clinical science sometimes supported by data. We're trying to change it to be a data science supported by clinicians. Now, the health nucleus, everybody's probably read about that. It's a $25,000 experience. That's for the platinum version. But we're introducing what we call the HNX, and that's what we're going to be franchising. Where right now it's only $2,500 for the complete genome and the complete MRI suite. And then we have a $7,500 version that adds on the cardiac CT and a bunch of blood work. We're not good at valuing healthcare in this country. Many women have had BRCA1 gene test that you don't care if your insurance company paid $5,000 for that one gene test. But if you're paying for it out of your pocket, all of a sudden $1,000 sounds like a lot to get all of your genes measured. Insurance is currently not covering this. I think it will as the data builds up because the preventative medicine aspect of this, especially for insurance companies, because we're dealing with categories that cause sudden death, cause you to pay out, whether you're self-insured or not, a lot of money because of somebody's health care that could have been managed much more readily. If you're interested in learning more, humanlongevity.com or healthnucleus.com. We're happy to talk to you about franchises or just coming down to find out whether you're healthy or not, because you can't tell me you're healthy, but I can tell you whether you are or not. So thank you very much.